Hello everyone, we are Simple Baseline from National Taiwan University, and our task is citation intent recognition. Here's our outline of the presentation. Starting from introduction, this contest presents research descriptions requiring the first three related papers from a huge candidate paper pool, which contains roughly 800k papers. Our team achieved the first place in public leaderboard but in second place or in private leaderboard. As for dataset, there are training dataset and testing dataset, of course, which contains description ID, description text, and for training dataset, there are paper ID as target. As for candidate papers pool, there are several attributes. Also, there are a ton of missing data. And we all know that for NLP task, preprocessing text is pretty important. So we first lemmatized every word and remove stop words and special characters such as punctuation. Finally, we lowered the text. Also, we extracted key sentences the same way as description in context website. Also, we replaced the sentence which is too short with corresponding preprocessed description text. Our approach contains two stages, recalling and ranking, which is just like typical solutions for recommendation-like problems. However, we employ 5 different recalling methods. Also, we prepared 217 features for ranking model to learn. As for ranking models, we train binary classifying models to rank the selected papers. Start with recalling methods. For BM25 and IDF, we concatenated preprocessed title, abstract, and keywords, and use all papers in candidate pool as corpus. As for sentence to factor, we should skip the lemmatizing step during preprocessing data because these lemmatized words might become out of vocabulary. Use this word directly would cause a terrible 2% drop in recall S3. However, this issue only affected Bluebird a little. We thus employed the same input as BM25 to Bluebird for convenience. For our first recalling method, BM25 has two tunable parameters, B and K1. The former controls how much effect field length normalization should have, while the latter controls how quickly an increase in term frequency results in term frequency saturation. In this task, we stick with the default values, which setting B to be 0.75 and K1 to be 1.5, since which perform the best. As for second recalling method, IDF, we found that unlike TF-IDF, in this text term frequency was not so important that we could improve recalling accuracy by around 1% if we only used IDF. Also, we discovered that words with lower IDF value were too common to be representative of document. So we have this formula. The third recalling method is sentence to factor. A sentence to factor is a sentence embedding model with simple but efficient unsupervised training objective. The algorithm outperforms the state-of-the-art unsupervised models on most benchmark tasks, and on many tasks even beats supervised models, highlighting the robustness of produced sentence embeddings. And also, we can easily see that the description texts will form biology kinds of papers. Therefore, we use these models, which is trained on biology papers, as underlying word embedding models for sentence to factor. Our fourth recalling method is Bluebird, which is also trained on biology papers. We all know that BERT is a state-of-the-art contextualized embedding, so we add a few recalls in a totally different aspect. Although there is a more famous BERT model also trained on biology papers called BioBERT, we found that BlueBERT outperforms BioBERT in this text. Finally, the last recalling method is from keywords. We discovered from previous methods that traditional IR methods outperform these deep learning ones. According to these observations, keywords also have two characteristics: long length and high IDF value. So we record papers by calculate the number of overlapping keywords. For the parameter, we set the top 10 longest words with the threshold 13. We record 87 papers for each description: 50 from BM25, 10 from IDF, 20 from sentence to factor, 5 from BlueBERT, and 2 from keywords. And this is the table of recalling accuracy of 5 recalling methods. Generally, contextualized embedding performs best in most texts. However, in this text, we can see from the performance of BlueBERT, contextualized meaning of sentence is not quite important for finding best matching sentence, while global word embeddings in corpus are much more essential. Sentence to factors thus significantly outperforms BlueBERT. This actually makes sense because the corpus contains large amount of terminology terms. Those terminology terms have the same meanings no matter where those terms are. Despite the fact that the recalling rate was not quite well in keywords, this recalling method was still essential for our performance. With only 2 recalled papers added, we improved our overall recalling rates by more than 1%, which showed how distinguished the papers recalled by this approach were. Next, we move on to feature engineering. In this task, we are asked to find the most mentioned papers for each description. Therefore, the distance between description and paper must be quite important for model to learn. However, we still employ 2 different directions of features for each recalled pair, and there were 217 features in total. The first was the attributes of description and paper. There are length of description text and key sentence, and whether the paper has abstracts and keywords. The second was distances between description and paper. Also, each description has description text and key sentences, and each paper has title and abstract. Therefore, there are 4 distances in total. For the raw text, we computed several distances including Jaggard similarity, Levenshtein distance, Jarrow distance, Jarrow-Rinker distance. Besides, we also calculated the BM25 score and the number and rate of overlapping common words, keywords, acronyms, and pseudo keywords. Pseudo keywords was generated the same way as the section of keywords in recalling stage. There are also several distances computed from embeddings. For each kind of embeddings, we computed distance including cosine similarity, Manhattan distance, and Euclidean distance. And we'll introduce the embeddings we used. IDF, sentence to factor, BlueBERT are the same embeddings we used in recalling stage. Work to factor, fast text, SIF, we use the mean of word embeddings in a sentence. As for SciBERT, SciBERT is another kind of BERT model pre-trained on scientific domain of papers. And we found this kind of embedding is also useful for this task. As for fine-tuned SciBERT, we used the structure of InfoSent and replaced sentence encoders with SciBERT. In particular, for this embedding, we only generated embeddings of description text, and paper's title, since it took us too much time to produce embeddings before the closing time of competition. Lastly, the ranking stage. We trained light GBNs as ranking model with stratified tenfold cross-validation. And here are our parameters. To ensemble 10 models from tenfolds, we use average and 3 other voting methods. For average, we calculate the average of logits from 10 models. And for voting methods, we only pick top 8 papers obtained by several tens of trials. First is linear weight. For the first paper, the weight is 8, and the next is 7, and so on. The second one is reciprocal weight. The first paper has weight 1, and the second has weight 1/2, and so on. And the last one is KR weight, which is inspired by online game called Rider, which gives scores to F riders by ranking of a game with the following weight. And finally, the KR weights outperform other methods no matter how we modify features during development period, and was first place on the private leaderboard. Hence, we only import this strategy on the private leaderboard and achieve second place on the final leaderboard. In conclusion, we conducted various recalling methods to reduce the scope of candidate papers. Next, we prepare over 200 features for classifying model to learn. Then, we train light GBN models using stratified tenfold cross-validation. Finally, we assembled by voting strategy with weights inspired by Card Rider. Also, we come up with some possible improvement for our performance, such as continue training biological word embedding models, using fine-tuned cyber embeddings as feature, tuning light GBN parameters such as objective function. Thanks for listening, and we would like to apologize for not attending the conference due to the outbreak of Wuhan coronavirus and our own safety.